This episode is sponsored by United Refrigeration and Westermeyer Industries, revolutionizing your HVACR experience. Visit URI.com for all your HVACR needs, offering real-time inventory, personalized pricing, and a nearby stock feature. Access quick pick replacement parts and branch details effortlessly. With 350 plus fully stocked locations across North America, our knowledgeable staff are ready to assist with the solutions you need. Exclusive offer. Use code ARPOD on URI.com to get a $10 gift card when purchasing the Westermeyer oil float, part number W4300-38F. These high-performance floats are not just compatible with their own oil separators, but also available as a crossover model, conveniently stocked at United Refrigeration. That's code ARPOD to claim your $10 gift card. Visit URI.com now.
The Sporlan division of Parker Hannifin Corporation is sponsoring this podcast. Sporlan is the leading manufacturer of HVAC and R components. Using quality materials and craftsmanship, Sporlan maintains a commitment to innovation, manufacturing excellence, service, and support for its customers since 1934. The company is known for its catch-all filter dryers, thermostatic expansion valves, solenoid valves, pressure regulating valves, suction filters, electric valves, controllers, supermarket monitoring solutions, chemicals, smart service tools, Zoom Lock Max, press to connect, and Zoom Lock Push to connect refrigerant fittings. If folks want to learn more, what do they do?
You can go to sporlan.com.
I guess that's Jim and John for Sporlan signing off.
Story of our lives. Good evening, everybody. Welcome to Advanced Refrigeration Podcast. You're the host, Brett Wetzel and Kevin Compass. You look tired and sick. You sound like crap.
Yeah, I feel like crap. I was out all night and I got woken up at midnight to a CO2 rack that went down in a storm that decided to just shit itself, and it blew the charge, and the high pressure valve driver burned out for the second time.
Sweet.
Yeah, this startup has been the startup from hell. Yeah, I spent my morning just getting the shit beat out of me by rack doors. It's 60-mile-an-hour winds, and it's just rack doors flying down on top of my head, the doors bashing into me, trying to get this rack to run. And so I ended up having to make a bush fix out of a Sporlan IB board.
You said you do stock those on your truck. That's pretty. I like the zip tie around the board. That's pretty good.
Yeah, it's I couldn't find any backings. Yeah, I made do with what I had on my truck. I took a Sporlan IB board, and you could put 0 to 10 volts to it out of the iPro, which is nice because it has the ability to throw the 0 to 10 out, or the 4 to 20 milliamp, and you could drive out an output of a valve. The only problem is it's made for Sporlan valves. So the steps are all off. So I had some figuring out to do.
Do you have the board where it's configurable? Because I know that they make like a universal one that has, that's the one you have.
That's the dip switches on there. So this Danfoss valve, particular Danfoss valve, is 800 steps. So your options are 500, 1596, 2500, and then 6000 for the CDS valve.
What was that? Sporlan IB board?
IB board, yeah. So what I ended up doing is I ended up taking a linear turbulator and figuring out at what voltage was going to be 800 steps out of 1596. So I took the 1596, plugged it into the linear turbulator, plugged a 0 to 10 in there, and just played around with it till I found what 800 steps was. And then I programmed the iPro to not go over that percentage.
Okay, so let me take a crack at what you ended up doing. So you said the thing had probably 1596 because that covers the gambit of there. And then you were like, okay, 1596 at 0 to 10. So 10 would be your 1596. So essentially you're like probably putting out what, 6 point or 5 point something volts. Like
Yeah, it was like,
your
I think
mid.
I went like 4.9 just to be safe because it shouldn't open all the way anyway. So, but like it throws off the scaling in the controller. It's almost double what it normally would be open, but I just sped up the PID and made it work faster. It worked. Like the rack is back running, like it's functioning, it's running, and it was running a little bit better. But I'm convinced now that all of these racks should have an IB board sitting in it.
It's just a spare.
Because the iPro, the nice thing about the iPro is it has a 0 to 10 volt output for the high pressure valve and the BGV.
Yeah.
So you could do a valve stepper or you could do a valve driver like this.
Maybe you should have had the snap-in track. I don't know why you didn't.
I threw away like 3 of these that had the snap-in track. I had like an entire box of these when I switched vans. And
I'm not going to need it.
Yeah, I was like, I haven't used this in like forever. So my other fix to this was, which the board looks sketchy, was to program an ESR board in. And this is the nice thing about the iPro having it on there, and with the E3 is you can network the valve percentages. So I was just going to network out the valve percentage to the stepper motor on the actual ESR, which I think it should have an ESR also.
These boards right here, is this the same distance as?
It's not.
No, it's not.
It's like
2.5 inch. Never mind.
Yeah, it's short. So I just zip tied it up there all hillbilly. It's only got to make it for a day and a half till the parts get here. But yeah, this is something special.
Yeah.
Just so you guys know, if you do use an IB board or any Sporlan product driver and you have a Danfoss board, all you got to switch is black and white. So black goes to white on the driver and white goes to black on the driver.
Right here.
Yep. So just switch black and white and then you're good to go. So that'll drive it functionally properly.
That was some creative thinking, though. I got to give you props.
It was some real. I was there at 6 a.m. after being up all day trying to get the linear interpolator to work, and I was like, I hate this right now. The wiring isn't the cleanest, but it's
going to get redone anyway. What's this guy over here?
That's the flash gas bypass valve.
So the BGV was working, but the HPV is the one that took a poop.
Last time it was the BGV that stopped working and wouldn't drive, and this time it was the HPV.
So these are new. So I haven't seen these before. These guys, these are the super caps, right? Yep.
So from my understanding, it's just 2 capacitors in there. It's powered up and it's acting as a battery to drive the valve shut.
Just upon a power failure. So you don't have to have that battery backup. So at least it'll fail shut.
So this rack had the battery backup and I don't know exactly what happened. Like it was all muffled. There was construction guys there and everybody was flipping out at like midnight when this thing went out, and it knocked out the rack controllers downstairs. It knocked out this. They had to reset the power supply because it has a battery backup. They had to go physically take it apart, pull the battery out, and reset it before it would actually turn the power back on the rack.
Interesting.
Yeah, and it was venting away. And then somehow the iPro lost all its PID settings.
Interesting.
So they all went to 0. Which
so
was
it was really overdriving then.
No,
really
it wouldn't
quick.
open.
Oh.
So I went to go start it back up, and after I did all that, I couldn't get the valves to open. I'm like, what the hell's going on? This was working a little bit ago.
Mm-hmm.
And as soon as it started loading up, like the PID was set to 0 for the subcritical.
Interesting.
So I don't know. I copied the PID that we normally use, and it took off like a rocket after charging it back up and getting it back going. But yeah, and then driving 2 hours home.
This is really pretty, though.
It's something. It's got ferrules. Look, it's got ferrules on it. I churched it up a little bit at the bottom. I dropped the first board right out of the van in a puddle of water. Like I was like, oh, you got to be. It's like 5:30 in the morning, and I was like, you got to be kidding me. I was like, could one more thing go wrong today?
Yeah, you got to drop the second board.
Thank God these came off like a remodel that Kaiser sent out like a giant box of parts that we didn't use any of it.
Yeah.
Like just randomly sent 20 IB boards.
Yeah.
I'm like, all right, this is van stock.
Good thing it was.
But I honestly think these CO2 racks should come with a backup of this. And like with the iPro, like throwing an ESR board in there that you could just move the points down and they're already mirrored.
Yeah.
Why not? It's a little bit more money.
Yeah. I was helping someone this week. They had happened to replace the HPV guts and the iCAD controller, and he went back the next day because the rack still went off on high pressure. And he said, "I don't know what the hell's wrong." I said, "Start sending me some graphs." And he shows me the graph of the flash tank pressure, and I was like, "That's a little high. I don't know if it's supposed to be that high." And unfortunately, it took me a little bit to figure out what was going on because the store he was at is a store that I haven't seen use microthermal before. And then I looked and I was like, I couldn't find where the node was that actually controlled it. I was like, I had him, he didn't, first I couldn't team viewer, right? Because if I team viewer, at least I could play around and try to figure out where I'm at. And I'm not the most proficient with microthermal since I really don't touch it anymore. And so I'm trying to have him touch this, but he's playing like Helen Keller with the phone, like all over the place. So moving all over there. And so I was like, I don't know. We need to try to figure out what the set points were because like they had the valves programmed wrong if it was being controlled by microthermal. And then I had him walk around to the other side and I was like, and he breezed by the control cabinet. I'm like, "Do you have a 326 in there?" He's like, "Yeah." I was like, "That's what's controlling it." He's like, "I thought microthermal was." Well, I said, well, apparently not. So the problem is that he had it wasn't opening up enough. So in the time that I was having him diagnosed, he went to go down to grab some more tools and I didn't hear back from him for like an hour and I'm calling him back and forth. Dude got his truck broken into while he was there. So he was really ornery and was real not focused then after that. But
I'd be pissed.
Oh yeah. So he ended up ordering a new CCM because he went downstairs to grab the valve driver and his meter because we wanted to see what was wrong. Was it the valve driver or was it the actual valve? So he ordered a new valve and came back and I guess he now ordered the last 326 in the country. Like the last one is finally gone.
I have one on the shelf behind me.
Don't say that too loud. But anyway, so he went there and because he was going to have to end up putting in a pack controller or having the customer who deals with that microthermal actually program it in to control then the HPV and the BGV because when he hooked up the new valve up the 326, it wouldn't drive open. It wouldn't do anything. Like his flash tank was just going all the way down to nothing. And because the HPV saw the flash tank was so low, it then started opening up the HPV just wide open. My suction is high as hell. I'm like, doesn't sound like it's closing. So he actually had his SMA on it. We ran the SMA in when he had it. He actually left the SMA on site in case anyone was messing around with it. And they went back the next day and it was just creeping right where it needed to be. It would go a little high, not really any lower, but like just a little bit higher than what it was supposed to be. But for all intents and purposes, it was holding true. And I guess he's supposed to get the controller in tomorrow because we even took the filter out of the circuit thing. Like you had recommended that we try to jump that out just to make sure, in fact, it wasn't just the filter messing it up. You know what I mean?
So with the SMA, with the Danfoss valves, remember, same thing as the Sporlan stuff, guys. Invert to black and white, and then it'll drive properly. And make sure your steps are like 100 on the SMA, or else it starts messing up. Now, I will say this though, the iPro out of the box keeps the receiver pressure just within a pound or two. But with microthermal having it there, their 2-valve controllers are awesome.
What controller would they have had to hook it up to?
So it'd be a 2-valve controller. So it's a 700 series board. So it's just any node. So that's the other thing. You could use any node. And you would have a 2-valve controller, which is a dedicated, it has 2-valve drivers on it and 8 inputs. So it has all the inputs you would need and the 2-valve drivers all on one board.
Gotcha. Is that a canned program that it has, or is that some special block logic program that you
No, it's a canned program. So it's part of the gas. You can make it a 2-valve controller or part of the gas cooler node, which or the condenser node. I like it when it's part of the condenser node because it does everything all in one. You're doing your condenser control, you're doing your fan control, you're doing your HPV valve control. All of it's all in one. It's not fighting each other.
Gotcha.
So that's my favorite go-to with that. It's a pretty simple swap over. Like you could use the Danfoss transistor still too.
Oh yeah, because you're just adjusting the scaling, right?
No, like they already have it set up. You could just choose the Danfoss transistor on there. And then if you want to use the PT1000 sensors, you could do that also. It's already all set up. You don't have to add anything else.
Gotcha. Man, I had nothing really planned for this week. What are we going to talk about, man?
We can go over some basic rack refrigeration. I've been seeing a lot of stuff like about subcoolers and like how to check basic rack stuff. So we can go over some like basic rack refrigeration 101.
Sure. After we just got in some detailed shit. Sure.
Yeah.
Here's some CO2 shit. Hey, we're going to talk about basic rack now. That's cool. I don't know. You start talking about subcoolers. I'm going to bring up a document while you're working on that.
So we can start talking about subcoolers. We can start talking about just like basic rack stuff. Like I see there's a lot of newer guys coming in. It's the beginning of summer. A lot of newer guys getting hired. So my number one thing is like when I go to a store, especially I've never been to, I will take 10 to 15 minutes and I will walk the machine room and just look at stuff and see how things are piped and look over everything. And if you could find a P&ID diagram, I've never really paid attention to one for a normal rack. It's just, most racks are simple enough where you could follow the piping, especially like a DX rack. Most of the time it's laid out large enough where you could trace the piping out. It's all open. So just looking through and follow the piping from the compressors to the condenser, then back down to the receiver and how all the valves are laid out. Like I will look, especially if I'm doing like a lot of work in a room, I will look where my main shutoffs are. So if there's an issue, like if we break a line or somebody does something.
I got an idea. And I agree with you, getting familiar where everything is. But one of the things that you can do, because if you don't know what it's supposed to be doing, right? If you could see what it's programmed for, but you don't know if anyone's been monkeying with stuff, right? One of my go-tos is trying to just look at the refrigeration schedule, because it basically will tell you everything that's going on with the rack, right? What kind of refrigerant it is, does it have split, everything about the rack, what the condenser TD, what saturated suction that it's trying to maintain. Like on this rack right here, we have two different suctions. We have a plus 13 suction and we have a plus 18 suction. First off and foremost, making sure if you're having problems with stuff, making sure that is in fact if the rack is running right at suction, or if it's not, if it's running a little bit higher, maybe that's why you got some cases. Also making sure, a lot of times you will see, so that this right up here, it says subcooler SST 35 degrees, subcooler liquid temperature 50 degrees. So like knowing if the rack is operating exactly the way it was designed, because if we get it back 90% of the time, you get it back to the way engineering spec was, it should work. Would you agree?
Yeah, the only thing I would watch with the subcooler SST is with the glides. Usually it's a lot higher. You could see some subcoolers 87 pounds of 448, and that's like a 50 degree around a 50 degree SST. So I mean that's your glide. Some of these heat exchangers are hitting 2-3 degree TDs, so they're super efficient. So that's one thing to keep in mind. Like some of these are raised up a little bit, and then like some of the sheets, just take it for a grain of salt. Also, there's been times that stores get remodeled 17 times and RS sheets never get updated. So,
what do you mean? That never happens.
Yeah, it never happens ever. It's never ever. And added 17 cases, and now the condenser is just running full tilt when it's 70.
Yeah, no, I get with you. So the other thing, this is going to make me a liar, because typically, so for the condensers, it usually will give you a TD, right where it actually says TD here. And so you can figure out if the condenser, that is, if like Kevin said, if it hasn't been remodeled 6,000 times to Sunday, right? Making sure that if someone keeps adding, let's add a bigger compressor, let's add some more compressors. If it's a fairly new refrigeration schedule that hasn't been monkeyed with, or the date is up to date of what it originally was, you should be all right. But so for the condenser TD, like I can look at this, and if it did have it on there and it says 10 degrees, anything above 75 degrees ambient, it should be able to maintain that 10 degrees. And what I mean by that is whatever the ambient is, let's just say it's 90 degrees outside. If it has a 10 degree TD, theoretically, it should be running about 100 degrees saturated condensing temperature on the discharge liquid side of the pressures.
Do not throw a sprinkler on it.
Wow. Yeah, don't do that.
Yeah, no, like that's one thing, especially you guys, these newer guys that are getting in here. Don't just go to the sprinkler. Is the crutch. Like, actually wash the condenser. It's the easiest work you'll do all week.
And usually it's because they're utterly compacted. You know what I mean?
Yes.
There's some things that you can do. Sometimes if you have two condenser fan motors that are sharing the same chamber of air, sometimes if you have one condenser fan motor out and you can't get that condenser in right now, sometimes you can cover up the other one, because if it is sharing the same air chamber and you have that one just sitting there going backwards in the breeze, essentially it's just bypassing the air. It's not pulling the air through the actual coil. It's going to pull it path least resistance. So just keeping that in mind too.
Yeah, making sure that the condenser is like clean, spotless, especially if you're walking into a rack and you're a newer guy, like making sure that condenser's clean. If you're there on a Friday, just clean the condenser. Don't screw the guy for the weekend.
What do you mean?
Yeah. Stop it. You would go ballistic at that.
I know.
Like ballistic. But yeah, it's looking over the schedules and finding your TDs and stuff like that, and just tracing out like your main circuits and seeing how everything's laid out.
Today's episode is sponsored by the RefRushield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP Series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
And I'm a big proponent of this because I have terrible ADHD, and looking for like switches that are off and marking them like off, because I don't want to leave a switch off or turn something on that's not supposed to be on. So just looking around and making sure you get your bearings with that, know where your main valves are. I don't know how many times I've seen guys in a rack room and they busted a line off of something and the whole room fogs out and they don't know what to do because they didn't know where the main shutoffs are and they panic. Don't panic. Just hit the switches and kill the mains for the ball valves and just get out of there. The refrigerant's not worth getting hurt over.
Yeah, it's gnarly because sometimes you won't even notice what's going on. Like if it's on a discharge line, yeah, you're going to see that fog. But I've been in a situation in a box where I didn't know it was leaking in there until I started getting the wah-wahs in my brain. You know what I mean? Like just being in there, I didn't even realize that it was that we had a leak until I was on the verge of, I'm going to fall over.
Yeah, it'll get you. It'll displace the air. Plus, it can't be good breathing all that shit in.
No, not at all. No, but that's the whole reason why a lot of these rack houses have some kind of emergency exhaust. You know what I mean? So you're not, around the controller holding your breath, like trying to get the override. And
I always wanted to break that glass.
You and me both. Have you ever broken the glass?
No, I got close one time. We were he's not an apprentice anymore. He's a journeyman, but he busted off the PRV off a Hill Phoenix rack where they like piped him underneath the skid, and it was on a piece of pipe.
Mm-hmm.
And he had a wrench and he had a pipe wrench backwards. He's a first year and he had the pipe wrench backwards and he went to go turn a PRV off and he sheared a piece of 1/2-inch black pipe off that had been getting dripped on by a compressor for forever.
Damn.
So he sheared it off and I watched the relief tree go hit the floor, hit the ceiling, hit the floor, and stick in the side of the rack house. And then it just went pure white. And like 4 of us were like running out the doors and like grabbing apprentices. And then 2 of us ran back in, hit the exhaust fan, and started shutting off ball valves and then saving what gas we could have. Thank God it was a gas conversion and it was getting converted that night. So it was just like limp. Yeah, we're going to have to shut down 2 of these circuits for today. And it's just causing problems. And they'll be back on tomorrow morning when we do the gas changeover.
It's absolutely horrible.
Yeah, I mean, I wasn't about to put 300 pounds of 22 back in it to make it run for 6 hours.
No, I got
But
that.
yeah, knowing where those shutoffs, guys, and then just tracing out your piping, like your suction lines, looking at what kind of EPRs you have. Like some EPRs have manual bypasses that are hot gas driven stems, and some EPRs have manual bypasses on them themselves, like Sporlan eye valves, where it's just the stem that goes in. And yeah, just making sure that those are set up properly and they haven't walked out, and making sure that you're looking to see what valves you have so you can familiarize yourself with the site a little bit. Don't panic and just because the manager's in there wanting this case back and going, just take your time and figure out what you got and what's around you. You want to bring up that piping diagram or no?
I was looking for the Super Plus one. Which one? Of the
I
one
don't
that
care.
we're just looking at?
Yeah, we do either one. The
Okay.
Super Plus one's simple too.
All right. So this
Every
one's
time I think of Super Plus, it's bad times.
what's it?
all I think about when those racks is burnt oil and like nasty smelling oil.
That's because you're thinking of Costco R22 low temp.
Just that. It's just we had tons of them out here that were just like in Independence and they were just beat.
This is a hot gas rack. Let's see, let's zoom her in a little bit. So this is would be, I believe this is our medium temp side. I believe. Yeah, no, my bad. Medium temp size over here. The low temp size over here. The reason why I was able to see that is just by looking at the diagram here a little bit. Zooming in, you got 13 degree suction, minus 13 degree suction, and the other kind of thing that was like, oh, why would you have hot gas on your medium temp? This is a hot gas rack. It might be doing hot gas on that one too. I'm not sure. We gotta look further into it.
Looks like you got pump out lines, which I think are like with big racks and big coils. I think it should be a standard having a pump out valve around an EPR.
This is weird. I don't know if it's a pump out because it looks like there's a check valve because this is the return. And I'd have to look to see what that valve is.
So what about on this side, on the left-hand side? Is that suction? Yeah. See how they got the valves around it?
Those two. Okay. So you got a smaller valve here and then the ME. Holy crap. ME43 on that one.
That's a hell of a fucking, that's a huge pump out valve.
Oh, which one? See, that's what I'm saying. I don't know which one the pump out valve is because look, they got an E3 here. And then whatever, see, I don't know what this number is. SC221. M43 is the pump out valve.
That's like a 2 1/8 valve, isn't it?
It's a big freaking rack.
Yeah, that's your pump out. Like for a lot of, like Costco's big on this with the older racks is they would have a pump out in there. And the way it would work is when the circuit would go back into refrigeration, it energizes a time delay relay.
Smaller solenoid.
Yeah, the normally close of that time delay relay is wired to the small solenoid, the pump out. And it's going to go for 5 to 7 minutes, longer the better. And it's going to pump out all that refrigerant in the coil.
Mm-hmm.
And then it's going to time out and it's going to bring on the refrigeration. If you start seeing header temp spikes or stuff like that or pressure spikes, it's from that. It's there to keep the rack from just getting smashed with liquid and hot gas after a defrost. And they work fairly well and they keep compressors from cycling. So that's one thing to keep an eye on.
So this is I think this is a bad representation of probably how big this thing is, but this is an accumulator that they have on here. And if you have an accumulator with 3 different glasses, and you also have a Hansen probe on there, that's telling me right off the bat that accumulator is probably freaking huge.
Oh, yeah. And then you got an oil drain.
Oil drain. The thing's big. And then on top of that, so you got these 2 lines right here. Typically what they'll do is the one of 2 things, right? And I'd have to follow the piping in order to see that. But either they'll usually run the drain leg of the condenser See if they do it here. Blah, 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 blah. So here's your condenser. Through there, through your receiver, through here, through a heat exchanger to common liquid. Medium temp discharge valve. No. But usually they'll actually run a line through here to do one of two things, right? You're putting either discharge or drain leg gas through this accumulator to essentially help boil off all the liquid that you're getting back. So yeah, they are preventing it a little bit with the pump out solenoids here, but then on top of it, you have this huge ass accumulator connected to it, which is basically acting like a buffer so we don't grenade our compressors here. Because if you look, and you could do, that has to be a huge accumulator. Look at the pipe size.
Oh yeah, that's a big accumulator. Like that's
6 1/8.
Is this 6 1/8?
Yes, it is.
Suction header.
Yes, it
I'd
is.
like to scrap a shit out of that. God, that's got to be steel or stainless.
I don't know. It's a regular 449 rack. It goes with the refrigeration schedule. I'm just now curious.
How much gas is in that thing? It's got to be.
When I looked at the print, I think I can go back to the print. It labeled it on the print. Hold on. Blah 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 blah.
And those are always wrong. So you add 400 pounds to 700 pounds to it. Like,
hold on. No, because I saw an 80% pump out. Oh, yeah, here we go. Pump down capacity 2600, 2696.
So it's probably got 2,800 pounds of gas in it.
Maybe.
Yeah, that is a big rack. So you guys normally aren't going to see stuff like this big. Like this should have been CO2 or ammonia. Like the state of California would have shit itself.
The rules are out now. It can only be a GWP of 150 for anything less than 150 pounds. Has to be installed before 2027. But yeah, you can still use HFOs out there. Just you need to get them installed before 2027.
There's no point. But like this rack, it looks like you got a subcooler on it. So
we do, yeah. So over here, so 7/8, and then 2-in-1 for the suction line. So they got some EEVs controlled by an ESR board. So they're controlling the superheat based off of that.
Okay, so that's a good picture of like how the Costco heat exchangers are.
Yeah, cross, blam, blam.
So when you generally, I figured this out the other day, when you generally have multiple circuits feeding one heat exchanger, you're going to be cross piped.
Nope, not all the time. Because I always put foot in mouth, and I looked. There's two different versions. There's two different versions of that heat exchanger that you're speaking of. One is on the one side where it's not cross fed. Because I looked, because after we had that conversation, it bothered me about the one rack that I was thinking about, and I was like, well, what happens if but it wasn't cross fed? It was straight up. I do say what you're saying. I think it would be more efficient either way if you cross feed it.
It's, from what I've always been taught, cross feeding is more efficient. You use more surface area of the heat exchanger, but like generally you're going to see stuff cross fed. Like I've never seen it where it's not cross fed. Not saying it's not out there, but like generally the Costco zero zone racks, they're going to be cross fed.
Yeah.
So it looks weird. Like it looks like you're like, hey, the factory piped this wrong, except it's not. It's piped right.
So another reason why you can tell this is a huge ass rack. Look what they're using for the defrost differential regulator.
What is it?
It's an ICM 65.
Oh, so it's an iCAD, like a steel iCAD driver? Yeah, that's a big rack. I'm a big fan of those valves. Those iCAD drivers work really well.
They're used a crap ton in industrial. Look, the discharge line is 4 1/8. It's a big one. Oh, here we go. So I was just talking about it, but I didn't know where it was feeding off of, and I just so happened to see this. So to medium temp accumulator, boil out inlet to low temp. So it's actually taking discharge gas off of there. So there's got to be, what's that?
And running it in.
Yeah, but what I don't know is where that discharge gas is essentially going to.
It looks like it's going back in the condenser. Because look, it says discharge to and discharge from. Boil inlet.
Oh, yeah. Okay.
So it's on the other side of the iCAD driver. So they're using that to make a differential to have your gas flow through it.
But I guess they're also utilizing that for, that would make sense, because then it's differentiating when it's in defrost, right?
Yep.
So then when you are pumping it out while it's still doing the differential, it would essentially cause the differential not only to get your flow in between here, but also get to your flow in between your discharge and your liquid line. So you had your backflow, right?
You could use them. Well, they're using it as like a discrete header, so they're dumping it back into the condenser lines.
Yeah. So your hot gas, because it has its own hot gas header and it has its own hot gas line. These are 3-line evaporators. So you're feeding it back and through. And so I'm assuming that it's just coming right back to the suction. It's not repurposing it back into the liquid, the typical.
So it's hot gas down. It's hot gas down the liquid line.
That's what I think. They might have and I don't know, because there could be. So on some industrial stuff, what they'll do is they'll use like a pressure regulator to maintain a certain pressure within there, like to maintain like 60 PSI or whatever. And I don't know if that's what they're doing here. I don't know enough about the programming on this rack. I have the program, but I haven't got the.
Well, it's like the Carnot racks. When they do their CO2, they do hot gas down the liquid line, and it comes back on the suction and dumps either into the. God, I always say this wrong. Like it's this intercooler. So
okay.
It dumps into the intercooler, which is essentially a accumulator, and it's also the receiver for the low temp, which is that on a lot of big systems, like a lot of industrial systems, they'll run the intercooler like that. So that way they could use the lower pressure, low temp liquid, or your liquid coming back and supply your low temp circuits with it.
This has so much stuff going on to it, because look, then you also have off the liquid line here, you have a low temp de-superheating valve. So you're pulling liquid off there, off that 7/8 line, also being able to throw it into this minus 13 degree header.
Which kind of makes sense. With something that big, you're going to probably struggle to maintain, like low superheats on like coils. This is one of those racks where you like 800 pounds is like not even a dent.
No, but I'm saying it's de-superheating. So like it's dumping liquid in here to drop the temperature down. If it goes into defrost too long, or it's bringing it back.
So that's something I've seen Zero Zone do lately. They've been adding liquid injection and hot gas injection on all their racks.
Yeah, I saw one when we talked about it on the CO2 racks, where like the one you're like, no, they usually don't do liquid injection. And then I didn't see it, and then I saw another couple racks after where they're really starting to do it.
Like even on their DX racks, they're adding it. Like they're. Yeah, like their HFO and HFC racks, like they're adding liquid injection and hot gas, and then they have accumulator heaters on them to prevent the flood back.
Oh, look, and they're also using the discharge gas here for the subfloor heat exchanger. So they're running the glycol through here.
Yep.
Just to keep the floor from a heave and hoeing.
Which you could probably do on a facility that big. You could probably get a lot of de-superheating off that. I see that disconnected on a lot of stuff, and like that plays hell on your head pressures, like stuff like that. Like heat reclaim tanks don't increase your head pressure, they reduce it.
Mm-hmm.
Especially if you got a decent load on there, you're taking away a lot of superheat off there, and that condenser coil is doing more. So you want to be able to have that heat reclaim running, and don't let anybody tell you that heat reclaim is a bad thing.
Oh, look what else they got here. So here's your 18-inch, your 18-degree section.
18-inch.
18-degree section. And then they have a crossover valve. I've seen this on some boxes where, like, on big facilities where they don't have a terrible big load, where the doors are shut, they might not be right on the dock or whatever, where it really doesn't need the capacity of the compressors that are down here, especially in the nighttime. But the freezers always do, because they usually always have something going into defrost and coming back into refrigeration. So a lot of times what they'll do is, this is essentially called, what I've been told it's called, load shedding. So if, God forbid, let's just say the load dribbles down to nothing, this EPR here, this is a Sport 17, is probably sized in such a fashion that, they could have this potentially set up as a compressor. So let's just say this is 30 horse, 30 horse, 30 horse. I don't know if that's it, and this could
probably
be
a little bit bigger than 30 horse.
When I looked at all these other ones were 6Ds. Maybe not. I don't know. I'd have to look. But anyway, so this could be considered what? Like maybe like a 15 horse. So if you don't need any of the physical compressors, instead of just short cycling these off and on, depending on what kind of load and unloading they have, which I don't know, I'd have to look at the electrical. But essentially, this can be used as another load. Essentially, now you're just using this as a compressor.
Yeah, and you want to set it so it's going to pull from the lower header. It's going to pull from the higher header. So what you'll do is generally is I'll shut down some of the loads on the other side and set it to where like a pound or two above whatever it's supposed to be at, like maybe 3 or 4 pounds. So that way it keeps the other header loaded all the time from ever shutting off. You should only be shutting off like down to one compressor. You don't want to be shutting down like you don't want it so loaded that it takes all the load off the other side, because that's killing your efficiency. You want it just loaded enough where if you were to lose load on the low side, that it's going to pick up some.
Yeah, it depends on how it's programmed, right? And they also have on this rack, it looks like a hot gas bypass valve. This would probably, if the load starts divvying off or the suction pressure starts delving down too low, this is probably the next thing that it's going to use to combat. And if it gets any worse, where it still can't keep loaded up enough with this hot gas bypass valve, hence now you have this load shedding valve to essentially take its place. I'd have to look at the sequence of operation just to make sure. Like usually with every rack, if you call, whether it be Hussman or Hill, they usually have a C02, which is a sequence of operation. Basically breaks down a lot of just how the rack is supposed to work, like how each one of these components is supposed to work. They also now have been giving you C02 racks that I don't know what any of these valves are supposed to be set for, whether it be the iPro or whatever it is. They're actually starting to give you a lot of the settings. Same thing with the VSD and stuff. So they're giving you a lot of the stuff that it should be. So you're like, hey, I programmed this all to what it should be operating. Why isn't it working now? Leave it in the hands of the engineer at that point.
My big bitch with all these new racks is though,
everything.
Like, why do we stop putting electrical prints on the doors? Like, why are we leaving them in books now and everything else so they walk away? It just drives me
never
insane.
Take anything.
Yeah, like why can we not just put the electrical schematics back on the door and just leave it there? It was fine like that for 40 years, and now it's off the door.
Stickers are expensive.
I started laminating some of these and like getting second prints because like it drives me insane. Because if you go into troubleshoot something, it's gone.
Never.
Thank God Zero Zone, if you email them, like they're pretty quick to send you like the entire packet. But who wants to look at an electrical schematic on their phone?
Yeah, no, that's no fun.
Yeah. So what is this? Got 4 banks of split?
No, I think it's just 50-50. See, look, there's only these two pump outs. So
what's the pump out? A 2 1/8 line?
I don't know. No, actually, look, it's only 3/8.
Oh God, that you're to be up there for it'll be pumped out by 24 hours at that point.
It has a solenoid, it has an orifice solenoid, but I don't think there's like because it probably goes because it doesn't matter. It's probably full. No, because most of the stuff that we have, it's ported. There's a little thing that looks like an OCV, but it's like teenier. And
or the spoiling valves with the port already in them.
Yeah, exactly. So this is basically just full on because it's going that huge ass accumulator. I still got to figure out how big that damn accumulator is.
Probably wouldn't even notice it.
No, not at all. No,
it probably wouldn't even have enough flow to even flood it.
You know what? I don't. Now that I'm thinking about it, because I looked at the rack. Hold on.
Oh, this is a rooftop mounted rack.
I think so.
What is that, like 78 doors on it?
I think so. Where was it? I just saw a picture. It had the.
God, this thing has to weigh like 300,000 pounds.
I don't know if it's on the ground or whatever. What's this? Air temperature, air unit, condenser. Dock. Oh yeah, it is on the roof. Oh shit. No, that's holy crap. Look at the capacity. It's a 2 million BTU condenser. Look at that.
So I thought once you get over 1 million BTUs on one piece of equipment, you would have an on-site operator.
I don't know where this rack is located. I haven't looked at that.
Chicago, if it's over 1 million BTUs, then they have to have an on-site operator.
Probably depends on the state, sir. I don't know what.
I thought that's a national code.
I don't know.
That's probably got like 2 Gutner like 14 fan gas coolers for a condenser.
Oh, it just yelled at me. Why did I do that?
Like those things are massive. Those condensers are like 40 foot long themselves.
What's that? Oh,
Those massive like Gutner like DX ones, like a 12 fan.
yeah,
Like, they're huge. Like I think they make a 14 fan too.
I saw one that it looked almost like a cooling tower fan. It was just straight. It was a straight V, but it just had fans, just one big ass fan right in the center, like the size of like what would be in like a cooling tower. You know what I mean?
Really? Once you get to that point, you're at cooling tower capacity. It's a size thing at that point. Like you're not getting anything bigger than that, like without going to a cooling tower. And then you bring in water treatment, and then everything goes to shit.
What do you mean? Water treatment's always done really well.
Yeah, because grocery stores do water treatment like phenomenal.
Actually, no. So here's the size of the. I finally found it. No, what happened was I deleted the file, and then it didn't delete it. Bango. That's still a big one.
That is a big ass gas cooler.
It is just condenser. That's all it is. Just a condenser. Weight. I'm not good at metric. 5,029 kilograms.
It's a lot of kilograms.
Yeah, I don't know.
Yeah, I don't do metric stuff. So.
I've never heard of.
What is it?
Kelvon.
So knockoff Gutner from.
No, I don't know. I've never heard of it.
It's like a Taiwan knockoff Gutner.
Oh, stop! You're such a jerk.
Getting it on Wish.com or
Temu.
Yeah, it's some Temu equipment.
No, I don't think so. Oh, holy crap! Okay, I found the accumulators. This is what I was looking for. How big the accumulator? But they're sideways.
Wow, that's a massive rack.
That's what she said.
That thing would suck ass to pick.
Yeah, because I don't know. Like I said, I don't know if this was. It said something about the condenser was on the roof, but I don't know if this is on the ground.
Put the receiver in there.
I'm trying to figure out which. Holy crap! Yeah, from here to here. So that must be
massive.
Is that the top? Yeah, that's the top view. Oh yeah, that is big.
Yeah, that is a massive rack. I like the industrial stuff like that. Like it's something different than just running supermarket stuff. And generally, it's a little different. There's usually more redundancy.
Okay, I'll agree with that.
There's usually more redundancy, and people aren't up your ass as much. And there's usually a lot more maintenance than run till fail. 28,000 pounds. There's no way that 4 rigging points on each side is gonna pick that thing up.
Well, 1, 2, 3, 4, 5, 6, 7, 8. Why not? It's only 448 inches long.
Holy cow,
that's big.
That is a big rack. Yeah, that's something. Like I want to talk about a little bit more industrial stuff because I'm starting to see it more and more. It's popping up.
There's a couple of people I'm actually trying to get on soon, so I got to call Ray again. After I call Ray, actually, Carnot, I think, is going to come on and talk about their stuff. I met with some peoples last week about them actually coming on and talking about some of their stuff, trying to get our neg to come on and talk about their stuff. And then I'm meeting with Carrier January, February, March, April, May. No, not until next month. But I'm trying to get them on there too because they're doing their first Carrier rack, I think, somewhere in the south. And that's, dude, I don't know if you've seen like the prints and stuff for that. Yeah, it's interesting because so there's no HPV.
Yeah, it's just usually
no human papillomavirus. It's just ejectors. And they're using all that excessive heat to reheat the oil because of the way their oil system is. All those compressors use PAG.
Yeah. I feel like we're making this more complicated.
It's worked in Europe for how long, sir?
Yeah, Europe also has a long time. They have another 10 years on this technology that we don't.
It could be longer.
Yeah, we're struggling to get guys to work on protocols.
All right. So this broaches a question, then we'll go. So like the CO2 class that I made for Cool System, I ended up making like while I was making it, and I can't just leave well enough alone. Like now it's like almost 600 pages, and it has like everything from 5 or 6 different manufacturers of racks, what we have in the United States, just to make sure we knew like sequence of operation and all that other stuff. When do you think technicians should start learning CO2? Because my problem is it's
within a year of them being in the field. Like they need to start. It's everywhere.
No, I get that, but I'm saying because we have a level system, right? Usually level 4 is when they start getting into racks. Like when do you really think they should start? We were going to start doing maybe level 3 and 4, like right before they start getting into racks, because eventually there is going to be some condensing units that are CO2. The only problem is the complexity of the controls, right? Everything below the liquid line from the bottom of the flash tank out is all regular DX refrigeration, no matter how you chalk it up, right? The only thing difference is the fact that CO2, we're actually working within the critical point, right? Like R22 has a critical point, 404 has a critical point. It's like 168 degrees saturated. But at that point, we've already blown the relief. But what I'm saying is that's the only real difference. And so the only thing there is the HPV, the flash tank, and the BGV is the only 3 things that make these racks really different. Would you agree?
Yeah, for the most part, the relief's venting off. I think once some like safety concerns change and like talking to Carnot about stuff like they're removing a lot of their check valves, which I think is phenomenal, and replacing them with warning stickers.
The other thing that I wanted to ask you about, sorry, one last thing. We were talking about how there's been you either have a leak on the receiver, or you have where the liquid indicator or the sight glasses are, or you have to replace that indicator, right? Whether it be a Hansen rod or whatever. How comes they're not making it standard that those sight glasses are off on a tree that can be isolated?
I don't know. It's pointless.
Every time you have to do something, like,
pain in the ass.
What do? You have to blow down the whole thing. Like someone was asking me, they're like, how do you do it? I'm like, how you do a regular rack? He's like, what happens if I have liquid left in there? I said, then what you need to do is just pump it down to whatever refrigerant level that that there isn't going to be jack shit in there, and then relieve that port out to get it below that level. And then that way, when you go to vent it, you're only ensured that there is vapor in there, right?
It does it pretty quick on its own. It's way quicker than you trying to do it. On its own, it does it real quick. I usually just get the pressure way up. And this is what I've been doing when I'm pumping these racks down. And I have had nothing but luck doing it. So if I know I got to shut a rack down, or if I got to do a bunch of work, I trap all the gas in the gas cooler now as much as I can.
And that's what I was curious. So if you have a ball up in there, can you fit that ball up in there?
Generally.
Yeah. Okay.
So I will shut the drop link ball valve, make sure I'm keeping an eye on the transducers, and I'll get it up to 1450.
Yeah.
And just try to trap as much in there as I can. And then if I'm shutting the rack off, I'll shut the suctions off, and because usually the suction release are lower, and then let it check back towards the receiver. If it's off for an extended period of time, let it check back towards the receiver and do its thing. But I trap everything in the gas cooler because your gas cooler reliefs are like 1,700 pounds probably. So that gives you so much more time to work on these. And when you're doing stuff, then blowing a relief, it's honestly been like foolproof. Like we had to do a power shutdown the other night. The rack was off for 2.5 hours. The pressure in the receiver went down.
Damn.
So we were able to trap almost all the gas in there. Obviously, if it's warmer out, it's it'll be one thing. But like I forced, if you get that receiver pressure out, try to pack as much in there as you can, and at the same time force discharge gas into that thing, and it'll keep the compressor running, and it'll start forcing all that liquid out of the flash tank and pushing it in the store and warm it up at the same time so you can vent it out and blow out the vapor. That's what I do, and it works really good. We've had a couple situations though where like we had a stepper valve and a suction fail, and it turned into a nightmare. Getting it out, it was like 400-foot line set.
The stepper on the suction for what?
For a circuit. because they're using EPRs.
Oh.
So that failed, and there was no way to pump it out.
Warning. The following stunts were performed by professionals. Do not try this at home.
So
Schrader.
I used the Appian.
Oh, just
It's 400 pounds, 410A rated. It did it.
But you're heating it up. Like, you're not.
But there's no resistance. It's going right to the suction header. It's really no different than probably shouldn't do it. But I mean, it sounded okay. It did it.
It didn't blow up.
No, it didn't. It's pretty hard to kill those Appians. I broke the crank on one finally, but it wasn't doing that. If you really think about it, you're pushing against 400 pounds. What's 410A? 90, 100 degree day if you're pushing in a recovery tank.
650, almost 700.
Yeah. So what's the difference? Those Appians they're tanks. I wouldn't do it like a field piece or like a nicer one, like DC driven, like the old Appian that you could toss down a flight of stairs and it just takes it. That thing, that yellow Appian G5 will just take liquid all day long. And apparently CO2.
I want them to be a sponsor now, just so you can say that. It just takes it.
It just works. It just does what it's supposed to do.
How the hell is a pilot track on a Plymouth work? It just does.
It just does. Didn't sound the greatest, but like it definitely recovered all that refrigerant out of there, like down to zero. Like I use the recovery machine quite a bit on the CO2 racks. I'm not going to use my nice big Navac one on it, but like that old Appian, she starts jumping. You just got to put the foot on there.
On that note, I think we're going to go. Shit. All right,
guys. Have a nice one.
See you guys next time.